So, good day, I'm Margaret Reyes,
And I'm Jester PAYE.
and we're going to discuss about the left turning tendencies. So, for example, you are riding an aircraft and during takeoff, you feel like you are swerving to the left. So, from that moment, we can consider that you are experiencing a left turning tendency. So, what is left turning tendency? So, left turning tendency, the single engine propeller driven aircraft enables an aircraft's nose or wings to rotate to the left. Also, the propeller creates a thrust that makes the planes what they are in the sky. So we have four unwanted effects. We have torque, P-factor, spiral, slipstream, and gyroscopic precession. So the first one, torque. So the origin or the concept of torque came from the Newton's third law of motion that for every action there is an equal and opposite reaction. So what is torque? So for a physicist point of view, um, torque is a turning force for about an axis. But if we're going to ask a pilot, so torque is a force that causes an opposite rotation. So the airplane receives a rotational force in an opposite direction when the propeller rotates clockwise. So when the propeller spins or rotates clockwise, the airplane or the aircraft experiences a rotating force in the opposite direction. So when the pilot applies a rapid increase in throttle, the propeller turns harder, causing the airplane or the aircraft to roll. So when the aircraft rolls, so we have an increase in torque and also increase in power. So we have to consider two scenarios here. So on the ground or during takeoff, and then when the aircraft is on the air. So during or on the ground, the aircraft will apply more pressure on the left tire that it will result in a more production of drag. So more right rudder to keep the plane straight down to the runway. But when the aircraft is on the air, increased torque effect on the engine will return to the propeller, thus the plane will experience or start to roll to the opposite direction. So when an aircraft is on the ground, it experiences a yawing effect, but when the aircraft is on the air, it experiences a rolling effect. So from this picture, we can examine or we can prove that the Newton's third law of motion is applicable because in this action, we can say that the propeller is turning hard to the right. But for this reaction, the aircraft is starting or wants to roll to the left. So the second one is P factor. So the concept of P factor is asymmetric propeller loading. So what is this asymmetric propeller loading? So asymmetric propeller loading means that the downward movement or downward moving propeller takes a bigger bite compared to the upward moving propeller. So P factor, a left turning tendency results from the descending propeller blade takes a bigger bite out of the air than does of the ascending blade. So the P factor adds to the left turning tendency when the aircraft or airplane is in nose high attitude. So we can consider this P factor when the aircraft is on the nose high attitude. So when the airplane is flying level, both blades of the propeller have the same angle of attack, but when the aircraft is in a climb, so the descending blade has a higher angle of attack, which means it creates more lift. So as a result, the aircraft will yaw to the left. So we have reasons to consider here about the P factor. It is due to the angle of attack of the propeller or due to the angle at which the relative wind meets the propeller. So the propeller takes a bigger bite of air on the right side, producing more thrust from the right half of the propeller, thus trying to turn the airplane to the left. So in this picture, we can see that the angle of the relative wind meets the propeller. And from that, there's a creation of thrust here, more thrust on the right side. So in this picture, it only means that at a higher angle of attack, the downward blade creates more thrust than those of the upward blade. So as a result, the blade or the aircraft will yaw to the left.
Okay, so for the next part, we have spiraling slipstream. Next slide. So the spiraling slipstream mainly revolves around propeller downwash. That means yung wind ng propeller natin actually affects the aircraft. So for the left turning tendency here, it occurs when the propeller is moving fast while the aircraft is slow, and is most common during the takeoff roll. So what actually happens? During the takeoff roll, the propeller of air generates a spiral of air that actually wraps around the aircraft's entire length. Now, as this air reaches the rudder, it actually parang pushes on the left side of the rudder, inducing that left turning tendency. So next slide, please. So considering our aircrafts, I mean, most aircrafts rotate the propeller clockwise. That spiral of air also follows a clockwise wrapping around the aircraft, which actually leads to the left side of the rudder. So imagine that there's an action there is some air pushing in the left side of the rudder, causing your aircraft to yaw to the left. So it's important to note that this is one of the easier concepts to understand regarding left turning tendencies. Next slide, please. So here is an example of an aircraft that has a visible spiral tendencies wrapped around its fuselage. So in some aircrafts, this actually will reach up to the end, producing that left turning tendency that we talked about. Next slide, please. So for the last part, from the easiest, now we go to the hardest concept to understand, gyroscopic precession. Next slide, please. So gyroscopic precession mainly revolves around space, rigidity in space, and precession. So the left turning tendency is caused by the rotation of the propeller itself. It's important to note that this is different from the torque, as the rotation there has a direct relationship with that left turning tendency. While here, the gyroscopic precession is merely, its left turning tendency is merely a byproduct of that rotation. So a spinning propeller can be likened to a rotating gyroscope, such as it has the same properties. Now, the left turning tendency is caused by that gyroscopic precession, which is when you apply a force to the disc, it induces a force that is felt 90 degrees in the direction of the rotation of the disc. So since most propellers rotate clockwise with respect to the pilot, this precession force pushes the right side of the propeller forward, inducing that left turning tendency. So next slide, please. So here we can see a gyroscope and its precession. So from the graph itself, from the GIF itself, we can infer that the gyroscope is rotating at this direction because it's rotating around this way. So as we mentioned, the rotation should be 90 degrees. The force should be at 90 degrees of the rotation. So why is this so? Well, that is out of the scope of this topic. So next slide, please. So in our aircraft, we have our propeller here. So considering now it rotates in a clockwise direction, and knowing that the force acts 90 degrees in the direction of the rotation will then push that right side, right side of the propeller, inducing that left turning tendency. Next slide. So here are our references. That is all. Thank you for listening.